to the front of 4.2 for a moment, okay? Just as a reminder, we learned how to find asymptotes, okay? We learned how to find vertical asymptotes and horizontal asymptotes. And we're going to use those, and we're going to look at graphs here in a moment. But do you remember how to find vertical and horizontal asymptotes? Vertical asymptotes, you're what? You're setting the denominator equal to 0 is how you find your vertical asymptotes, right? Okay, so keep that in mind. And horizontal asymptotes, remember you're looking at the powers. Biggest power on top, biggest power on bottom. And if the powers match, we're using the coefficients out front. If the bigger power's on bottom, the asymptote is y equals 0. And we probably won't run into a bigger power on top scenario in what we're doing right now. Okay? So that's what we focused mostly on Friday, or I want to say Friday, Tuesday, whatever our last day together was, okay, was our vertical and horizontal asymptotes. Well, now on the back side, we're going to use asymptotes along with x and y intercepts and maybe a few other points to look at the graphs. Okay, so that's what we're going to practice doing here. Now, when you guys go do these graphs in Savas, the graphs will be multiple choice. So it'll be more about just knowing where your asymptotes are and then which sections your graphs are in. So I don't know, I'll tell you guys up front, these graphs, if you remember our inverse variation graphs where they were the two opposite quadrants, that's what these graphs are going to look like, whether they are these two opposite quadrants or these two, okay? But it's always going to be those diagonal quadrants. That's what our graphs are going to look like today. So, as we look at this, it says graph each function. Start by identifying asymptotes and intercepts. So we're going to start with asymptotes. And I kind of have this broken into 3 steps, so to speak. So step 1 is going to be asymptotes. We're going to start with our vertical asymptotes. And if you recall vertical asymptotes, how did we find those? We're going to set the denominator equal to 0. So my denominator equal to 0 here is going to be 3x minus 4 equals 0. I guess I'll write it down once here. Denominator equal to 0. So 3x minus 4 equals 0. That means I'm going to what? Add 4 to the other side. So 3x equals 4, and then we're going to divide by 3, and x equals 4/3. Okay, not ideal. Sorry, we've got some fractions happening on this page, but fractions are a part of math. They're a part of life. So we have a vertical asymptote at x equals 4/3. What is 4/3? It's a little bit bigger than 1, right? It's 1 1/3. So I'm going to go ahead and draw this in. So a vertical asymptote of x equals 4/3, a little bit to the right of 1. So my vertical asymptote is going to be somewhere in that ballpark, right? Somewhere in between 1 and 2 is about the best you can make it in terms of being precise there. Now, while we're here, let's also find our horizontal asymptote. Okay. In terms of horizontal asymptote, remember you're looking for biggest powers. What's the biggest power on top? Big. Okay, it's that 2x to the first term. What's the biggest power on bottom? It's also an x to the first, right? 3x to the first. What was the rule when the powers match? If the biggest power on top and the biggest power on bottom match, we're using those coefficients out front. So my horizontal asymptote, since these powers match, are going to be the 2 and the 3. So y equals 2/3. Okay, so that's your horizontal asymptote, like the horizon. 2/3 is what? Bigger than 0, but less than 1. Again, I know it's hard to get very precise here. Do the best you can. So there's my horizontal asymptote. So what I know now, okay, my graphs that are either normally in the first and third quadrant or second and fourth quadrant, Well, now they're going to be in these within the asymptote. So they're still going to be either upper right and lower left, or upper left and lower right. We've just got to find out a little bit more specific of where. So after we do asymptotes, my second step is going to be intercepts. So we're going to find our x-intercept and our y-intercept. So I'm going to start with x-intercepts. Now, the easy thing to remember about whether it be x or y-intercepts is you're always using zeros. The x-intercept is going to be where the graph crosses the x-axis. So officially to find x-intercepts, it's always by letting y equal 0. Okay, that's how you always find your x-intercepts. In this situation, y is f of x. When does a fraction equal 0? Fraction equals 0 when which piece of the fraction equals 0? The top, yes, the numerator. So when we're dealing with these fractions, in order to find our x-intercept, we're always going to set the numerator equal to 0. Okay, so in this case, my numerator, being 2x plus 1, set it equal to 0. So I'm going to subtract 1. 2x equals negative 1. Divide by 2. X equals negative 1/2. That is my x-intercept. X equals negative 1/2. If you want to think about it as an ordered pair, it's negative 1/2, comma 0. With that in mind, I'm putting all this stuff on the graph as it comes. Okay, so x-intercept of negative 1/2 on the x-axis, I'm going to go left, half the box. Okay, so that's my x-intercept. Let's also, while we're here, find our y-intercept. Okay. X-intercepts happen when y equals 0. Y-intercepts are going to happen when x equals 0. So for this one, we're going to let x equal 0. And in terms of letting x equal 0, go put it into your original equation. So I'm going to be looking, what do we have here? We're putting it up here, 2 times 0, 0 plus 1 over 3 times 0 is 0 minus 4. So 1 over negative 4. Or in other words, y equals negative 1/4. And you can write it like that. Or again, ordered pair, 0, comma negative 1/4. And if you put that on the graph, it's going to be right there.
That looks like half to me,
yeah,
Mrs.
well,
Sargent.
We're going to take it as we can take it there. My negative 1/4 and my negative 1/2 on the x and y are very close to each other. Yes, how can we help you?
Just the two ramps there and Mr. Bledsoe, when you get a chance, maybe at the end, I don't want to take away
Okay.
your instruction.
Okay,
Please.
I'll send them down.
Thank you.
He's scheduling your final exam. Okay, now, as we get used to this, me personally, I know what my graph is going to look like at this point. I can draw my graph and I'm done. I can move on. Now that's me as the math teacher. You as the math student probably still need a little bit more here. But here's what I can tell you personally, and we are going to do a third step on these, but you see these 2 points down here, yes? That what I know right now is that part of my graph is down here. Make sense? Now, based on what I told you about what these graphs looks like, is part of my graph is down here and bottom left. Where's the other part going to be? The top right. I don't have any points showing me that yet, but that's where it's going to be. Now, in all honesty, could you stop here, put those graphs in, and move on and be done with this problem? Yes, as you know, we're not getting truly precise. Okay, but for what we're doing, you can. And Savas, it'll be a multiple choice pick at this point. So Savas, it will be, okay, get your asymptotes in the right place, and then get your graph in the right two corners, and you'll be good to go. Now, I am going to do a step 3, and I think it'll be helpful in this scenario so I can kind of prove to you what I just told you. But my step 3 is just coming up with, I just call it other points or extra points. It's just coming up with a couple extra points to show you, prove to you what I just told you. Some of you will skip this step and be perfectly fine. Some of you will want this step. Okay, it's going to be a you do you thing, but you're not going to have to do this step. But all I'm going to do is I'm going to set up an XY chart, and I'm going to pick a couple extra points. Now, what I like to do is I like to look at my vertical asymptote. My vertical asymptote is 4/3. So what I like to think is I want something on the left and something on the right. So 4/3 is, say, 1 1/3. A number below 1 1/3 is 1. A number above 1 1/3 is 2. And that will just kind of show me where my graph is going. Now, I'm going to plug 1 in. 2 times 1 is 2. Plus 1 is 3. Over. 3 times 1 is 3. 3 minus 4 is -1. And 3 divided by -1 is -3. So one ordered pair that I know is 1, -3. Well, from the origin, if I go right 1, down 3, does that just barely keep me on the left side of that asymptote? Just barely, yes, but it keeps me there. Let's try the same thing with 2. If we plug in 2, 2 times 2 is 4, plus 1 is 5. 3 times 2 is 6. 6 minus 4 is 2. 5 halves, or 5 divided by 2 is 2.5. Think about where that ordered pair is. From the origin, if I go right 2, up 2.5. Now, think about it. It's on the right side of the vertical asymptote, yes. And where does it put the other piece of this graph? It puts it up here. Now, if you don't have enough confidence there, could you do some numbers bigger than 2 and see what they come out? You can. But here's what I'll tell you guys. We can graph this in terms of down here in the bottom left, it's going to run very, very close to my x-axis. But it's going to look something like that. In the upper right, I'm going to mimic that shape. I know I only have 1 point, but I don't want to spend a bunch of time on this. 1 point's enough because it just tells me it's up here. And I'm just going to mimic this shape up here. And it's going to look something like that. Okay. I'm looking for a general location of the graph. Okay. I'm not needing you to get really crazy specific about what points it goes through. Okay. Questions I can answer here. Do we kind of follow that? Okay. Let's try B. Okay, new graph. I'm going to follow the same 3 steps. Step 1, I'm going to find my asymptotes. How do I find my vertical asymptote? Set my denominator equal to 0. So x plus 8 equals 0. If I subtract that 8 over, I'm at x equals -8. Not that you have to go ahead and put it on the graph now, but that's what I've just been kind of doing. At least it's a whole number this time. However, My graph has moved left 8, yes? I will say when you're doing this in Savas, half of the battle is if you can pick out where your asymptotes are. The thing is, they're going to show you some asymptotes at -8. They're also going to show you some asymptotes at +8. So be confident in knowing which way it goes. What about horizontal asymptotes? What do we have going on there? Biggest power on top is x to the first. Biggest power on bottom is x to the first. When the powers match, what do? Use the leading coefficients. And what are my leading coefficients? 4 over 1, or in other words, y equals 4. Okay, this is a horizontal asymptote, like the horizon. So it's going to go through the y-axis at 4. So I'm going to count up 4. Okay. Now, yes, my asymptotes are off center. Okay. That's how some of them are going to be. We're still going to have the same thing. It's going to be either upper right, lower left, or upper left, lower right. Okay? So after you've got your asymptotes, you're placing it. Use your intercepts to see where your graph goes. So I'm going to start with x-intercepts. X-intercepts happen when y equals 0. And how do we make y equal 0? That's setting your numerator equal to 0. So in this case, 4x minus 3 equals 0. Add 3 to the other side. 4x equals 3. Divide by 4. X equals 3/4. So that's an x-intercept at 3/4. If you want an ordered pair, it's 3/4 comma 0. So from the origin, I'm going to go right 3/4, up or down 0. You're doing this in Savas. I would argue you have enough information to pick a Savas graph now, probably. Just because of the options they give you. Because where's part of my graph going to be? It's going to be here in the lower right corner, yes? Where's the other part probably going to be? Upper left. Are you catching on to what I'm saying there? Like, use that information to your advantage. Okay? Now, we're learning. I'm going to keep us going, but I'm trying to get you guys to see the shortcuts. Okay, y-intercepts happen when x is 0. So plug 0 in for x. 4 times 0 minus 3 over 0 plus 8. 4 times 0 is 0 minus 3. 0 plus 8 is 8. Y equals negative 3/8. If you want the ordered pair, it's 0, comma, negative 3/8. Now, this is my y-intercept, so what's that mean on my y-axis? Practically touching the other dot. At least on my paper, probably on your paper too, because pencils can only go so small also. Okay? Now, for proof, let's pick a couple other points, extra points if you will. If you recall, my other points I like to pick. I like to find my vertical asymptote. I want one on either side. Now, in all honesty, we kind of know where this graph is on the right, yes? What I definitely want is I want a number to the left of my vertical asymptote that proves my graph is going to be up here. Okay, my vertical asymptote was negative 8. So for me, I would probably do -7 and -9. Because those are numbers on either side of -8. Now, do you have to get that close? You don't. But that's just my way of doing it. Okay? There's options out there. Okay, not the easy math this time. Let's see. 4 times -7 minus 3 over -7 plus 8. 4 times -7 is -28. -28 minus 3 is -31. -7 plus 8 is 1. So -31 over 1, -31. We'll talk about that here in a moment. Let's put in -9. 4 times -9 minus 3 over -9 plus 8. So what do we have here? -36 minus 3, -39. -9 plus 8 is -1. A -39 divided by -1 is a +39. Okay, well, -9, 39, and -7, -31. Do those prove to me what I need them to prove to me? I can't really graph them. But that doesn't mean they don't prove to me. -7, -31. So -7 is where? That's on the right side, yes? And where's it going to go? It's going to go way down here somewhere. Does that keep with the rest of this graph? It does, okay? All we know on this piece of the graph is that it's down here. Something like that. Okay? -939. Can I graph -939? No, I can't, but look, -9 is going to be on the other side of the vertical asymptote. Up 39 means what? Does it put me up here where I want it to? Yeah, it puts me in that upper left corner. Now, do we have exact preciseness here? No, but I know it's in that upper left corner. Are you understanding what I'm saying here? Okay, you know the shape of the graph, use that to your advantage. Some of you, as you get used to this, you can stop sooner in your steps than later. Okay? Okay, questions I should answer here. That was kind of a unique one with how it worked out. Okay, let's try C. You ready for C? Make sure I'm not moving the screen too soon here. Okay. My step 1, my vertical and horizontal asymptotes. So vertical asymptote, what about the vertical asymptote? Set your denominator equal to 0. X plus 3 equals 0. So I have a vertical denominator. Vertical asymptote at -3. Vertical, so I'm going to count left 3 on my x-axis. There's my vertical asymptote. Okay? Know that because right there, you're probably going to eliminate half of your multiple choice options in SOPAS by just getting the correct asymptotes. Okay? Horizontal asymptote. How are we going to do the horizontal asymptote? Using the biggest powers, right?
Yes. Thank you.
You're welcome. What's my biggest power on top? -1. I mean, it's an x to the 0 there. Okay, what's my biggest power on bottom? That x to the first, yes? Where is my bigger power? They don't match this time, do they? Bigger power's on bottom. When the bigger power's on bottom, what's the rule? The bigger power's on bottom. The rule is y equals 0 every time. So in this case, I had x first on bottom. I had no x on top. So it's y equals 0. Y equals 0, when I draw that in, horizontal asymptote y equals 0 is the same as the x-axis. Okay? So now we have our 4 pieces of the graph, right? Use some intercepts to help you figure out what's going on. So if we start with our x-intercept. X-intercepts happen when y is 0. What's that mean up top? It's setting the numerator equal to 0, yes? What is my numerator? -1 equals 0. It's just a not true statement. There's no x in that statement. So what's this mean? This means that there is no x-intercept. Now, in all honesty, that makes sense that there's no x-intercept because the x-axis is an asymptote. So that's not surprising at all. Y-intercept. Y-intercepts happen when x equals 0. So y equals -1 over 0 plus 3, or in other words, y equals -1/3. This is a y-intercept, so you could put it as the point 0, comma, -1/3. I'm giving you options here. Okay, on the y-axis, we have an intercept of -1/3. Okay. Most likely, that one point there, along with my asymptotes, would give me enough information to pick the correct graph and solve this. Because where do we know one piece of our graph is going to be? Lower right, yes? Where are we going to assume the other piece is going to be? Upper left. Okay. Now, how can I prove that to you? If you have any question in your mind, you can pick some other points and plug them in and see what happens. Okay? And so, with that in mind, have you figured out what kind of other points I like to pick? I like to pick points that are opposite sides of the vertical asymptote. So if my vertical asymptote is -3, I personally am going to pick -2 and -4. So if I put in -2, it's -1 over -2 plus 3 is 1. -1 divided by 1 is -1. So the ordered pair, -2, -1. Left 2, down 1. Okay, that makes sense, yes. That's in that same corner as that y-intercept. If I put in -4, well, it's still -1 over -4 plus 3 is -1. -1 divided by -1 is +1. Where is -4 +1? Left 4 up 1. Did that put me in the diagonal corner? Okay. So, do I have enough information to pick the graph off of Savas, to draw a rough sketch of the graph? And that's what I need. That's all I need you guys to be able to do. The fact that I can see this graph is going to be down here. If I hit those points. Over here, we only have 1 point, but I know that what that means. Ooh, that's a little rough. Looks something like that. Okay? I'm not looking for specific graphs. I'm looking for get the asymptotes in the right places and then you know which corners figure out which corners your graph are in. Got it? Got the gist of what you're doing? Okay. We've got one more here. And then you guys should be able to use a little bit of work time. 3x plus 2 over x minus 1. Can you stay ahead of me? Step 1, I like to do my asymptotes. That gives me an idea of where my graph's going to look at. And again, in Savas, that's going to be eliminate half your answers. Set your denominator equal to 0. So vertical asymptote of x equals 1. So vertical going up and down. X equals 1. Okay. After your vertical asymptote, you're finding your horizontal asymptote. Horizontal asymptote. Biggest powers. Biggest power on top. 3x to the first. Biggest power on bottom. 1x to the first. Powers match. So we're going to use y equals 3 over 1, or in other words, y equals 3. Horizontal, like the horizon. So horizontal asymptote of 3 is going to take me up 3. Okay. There's half of what you need to pick out the Savas graph. Intercepts. Intercepts should hopefully pinpoint which directions this graph is going. X-intercept. Well, x-intercepts happen when y is 0. A fraction is equal to 0 when the numerator is equal to 0. 3x plus 2 equals 0. Subtract 2. 3x equals negative 2. Divide by 3. And I have an x-intercept of negative 2/3. If you want the ordered pair, negative 2/3, comma 0. Okay. X-intercept of negative 2/3. On the x-axis, we're going 2/3 of a box left. That 1 point can probably tell you everything you need to know here. Okay. We can check our y-intercept. Y-intercepts happen when x equals 0. So, what are we doing? 3 times 0 plus 2 over 0 minus 1. So we have y equals 2 over negative 1, or y equals negative 2. As an ordered pair, that's 0, negative 2. Okay. Y-intercept on the y-axis, down 2. Does that make sense? Yeah. Okay. When it doesn't start making sense is when you end up with points in neighboring quadrants and they're not supposed to be there. That's when it doesn't make sense. Okay? You could stop there and know enough. Or if you want some other points to confirm. What kind of points am I going to pick? Points on either side of my vertical asymptote, yes? Now, my vertical asymptote is 1. So to me, my points on either side of 1 are 0 and 2. In this scenario, though, don't we already know 0? I mean, we already know 0 and -2, which that's the section I'm confident in. The section I really want to check is 2. Where should 2 point me? 2 should put me upper right, yes? Check it. If I plug 2 in, 3 times 2 is 6, plus 2 is 8, over 2 minus 1 is 1. 8 over 1 is 8. What about the ordered pair 2, 8? Right 2 from the origin, up 8. Does that put me in the correct corner? Okay. So, in this one, based on our asymptotes, we end up with a graph, the bottom left, and upper right. Okay. Again, as you become more familiar with this, and depending on the problem, you can definitely slow your, stop your problem towards, earlier. Don't necessarily have to have the other points. You sometimes know enough ahead of time. Okay. Okay. You have some homework in 4.2 Savas to be working on. I don't remember how many there are, but I don't think it's too bad. You're going to be looking at the graphs. You're also just going to be finding some asymptotes. Okay. Some of you need to go back and get caught up on 4.1. I put a whole bunch of zeros in yesterday when Skyward finally started working again. So that's the other thing I would say to check. Okay.